Video, what we're going to do now is we're going to create a type. We're going to create some kind of a type. And again, I'm pulling this example right from the book Learn Your Haskell. And the type that I'm going to create here is so let's do this. Let's just first draw some kind of a boundary here. So let's just separate our board over here. Okay, so this is what we're doing in the last video. All of this thing over here. And let's just create a new type here. So I'm going to say in this case, I have a type and I'm going to create a new type. So I'm going to use my keyword data. And this type over here is data, and my type constructor frank a b equals to, and my value constructors. So for my value constructors, I'm going to say it just has one value constructor with the name Frank as well. And this is the field inside here is Frank field, and the type of this is actually PA. All right. So this is the type that I've just created here, and let's see if I can at least just using this type, if I can figure out what is the type signature for my value constructor Frank. So if I look at this value constructor, so again let's just outline certain things here. This Frank over here is basically what is my value constructor. This is a value constructor. What is a value constructor? Well, it's just, think of it as just a method that takes in something as an input, a value, and gives you back something as an output that happens to be another value. This piece over here, this Frank over here, is basically my type constructor. This over here is my type constructor. What's a type constructor? A type constructor, in some case, is still a method. It's still kind of a special method. But what it does as an input, it takes in as an input maybe some types, and it will give you back as an output a new concrete type there. Okay. So let's take this value constructor, which is again, I just want to make sure I'm always consistent with my colors, so it becomes a little bit easier to understand what's going on here. So the type signature for my value constructor Frank, if I were to outline this, what does the value constructor Frank do? The value constructor Frank takes in as an input. It takes in as an input something that happens to be of type BA, and it gives you back as an output something that happens to be of type Frank AB. Okay, this is a type signature. This is a type signature of your value constructor Frank. Okay, what is the type signature for my Frank field here? So the type signature for Frank field is that it takes in as an input. It takes in as an input some value that happens to have a type of Frank AB, and it gives back as an output some value that happens to have a type of BA. Okay. Now, given this idea, at least even if I were to look, let's take an example. Let's say I were to look at this type signature of a Frank field, and I would just like to call the method Frank field. I want to make a transition from this type world into the value world, and I want to make a transition from this type world, which is in green, over to a value world, and I want to figure out how I'm going to even call this method. So to call this method, well, I need to call my method Frank field, Frank field, and now I need to pass in some value that has a type of Frank AB. Now what does that even mean? What is that value? What is that value that's going to have a type of Frank AB? And for that question, my other follow-up question would be, what is this A in this case? What is this B in this case? And uh, 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 even if I figure out what A and B is, would that really help me in figuring out how would I actually create some kind of a value that happens to have a type of Frank AB? All right, so how would I do that? My first question, actually, at this point, is before I can actually concretely lay this out in the value world, I still need to figure out what are these A's here and what are these B's here. And because I'm right now in the type world, in this type world which is in green, I know that this entire thing, this entire frank AB, whatever the type of frank AB is, the kind of that is going to be a concrete data type. So it's going to have a star, and the kind for this BA, the entire BA, is also going to be a star. All right. Okay. So knowing that now, I can say at this point. Frank of AB, I can say that, or even if I start with something, let's say start with BAO, that would be easier to start with. So I can say that, let me do it over here. So B is something, okay, B is something that has a kind where it actually consumes a concrete type A and gives back as an output another concrete type, this entire concrete type star. For A, the kind for A is nothing but just a star, right? I'm going to assume A is just a concrete type, and B is something that takes in this, it consumes this concrete type and gives it back as an output another concrete type. Okay, so I still don't know what B and A is, but I know what their kind is. I've got their kind, and this kind would allow me, at least help me to figure out what is the appropriate type constructor B could potentially be, and what kind of a type A could actually be. Okay, so knowing A and B, I can now say that this frank of AB is basically something where I can say this as frank of A and B. I can write this as frank is acting as a type constructor that takes in as an input, it takes in as an input this star, which is my A. It then takes in as an input another parameter B, which is this star to a star. Okay, so this is my A. This entire thing over here is my B. Both of these are being passed as parameters into my type constructor frank there. So what is frank then? How would I actually portray frank out? So frank is basically has a kind that it takes in the star, and it takes in the second parameter from a star to a star, and it gives back as an output. It gives back as an output this entire thing. Remember, frank of AB, the entire frank of AB over here. This entire thing, frank of AB, is basically a star. So it gives it back as an output, a star there. This is what actually frank is. The kind of frank is. Now, this is interesting because in some sense, what I have now is that the kind for T in my class type has a kind that goes from a star to a star to a star to a star, and the kind for frank is basically something that goes from a star to a star to a star to a star. So if I were to create an instance of my class, if I were to create some instance of my type class tofu, I at least now know what T should be in this case. T is something that can simply be frank here, because frank and T both have the same kind. So I could create an instance here of my type class tofu. So I could start off with saying instance tofu frank, where I'm going to say at this point, I need to implement my method tofu. So that's my method tofu, and tofu takes in some value. It now remember at this point I'm in the value world. So I'm going to say it takes in some value. Let's call this value x. It just takes in some value x that happens to have a type. It happens to have a type of JA. Okay, this is a type JA. X happens to have some type of JA, and this is going to be equal to what now? Well, it needs to equal to some value. It needs to equal to some value that happens to have a type of TAJ. It needs to have a type of TAJ. Can I make this a little bit specific? Like now I already know what T is. I know that T is basically in this case a frank, right? So I'm just going to rewrite this. I'm just going to rewrite this as uh, let's do this. So that's my J, A, and in place of T, I'm going to write there as frank. I'm still in the type world. Remember, I'm still in the type world here, and it's going to be frank A J. And so what I'm saying now is that if I have some value of type JA, I need to give back another value that happens to have a type of Frank AJ. Now, how do I create some value that happens to have a type of Frank AJ? I can create anything of type Frank AJ by basically going to the type definition of my class Frank and look at the value constructor, because this entire value in green has a type of Frank AB. So again, just to make this a little bit clear, what does Frank of AJ would look like? So let's do this. Let me just make a change right here on my type. So Frank, instead of B, this is now J, and this over here is basically a J. All right, so Frank of AJ, if I want to create any value that has a type of Frank of AJ, I'm just going to invoke this value constructor, right? I'm just going to invoke this value constructor. What is the type of the value constructor? The type of that value constructor is right here. It's saying it takes in as an input something of type BA and out comes back something of type Frank AB. Now again, my B in this case is basically a J, so I need to pass in something of type JA, and out comes back something of type Frank AJ. So what I really need to do here is I need to basically invoke my type constructor Frank, okay, right there. But as long as I pass in some value that happens to have a type of JA, I'm going to get back as an output something that happens to have a type of Frank AJ. This and that would definitely satisfy the behavior specs of my method tofu. All right, so what is that value? What is that value? Or how do I create that value that happens to have a type of JA? Well, I already know that this x over here that I'm passing into method tofu has some type, and the type for this x is right there. It's a type that happens to have a JA. So if I take Frank, all right, if I take this value constructor and I pass in a value which happens to be just x right there, this is going to be equal to, this is going to be equal to, this is going to be equal to this entire thing, this entire Frank x is going to give you back some value which happens to be of type Frank of AJ. So I hope this was useful in trying to understand. I believe this was a really, really good example. It's kind of a silly example because it isn't really useful in a practical sense. I mean, what is this tofu and what is this tofu with a lowercase t? But the reason this is really useful is because it gives us a very, very, very good basis in trying to connect some of the material that we've been using with Haskell types, with type classes, and putting the two together in a very, very decent understanding of some of the material that we have been learning all this time.